go to Debian org and click on Other Downloads. On this page, we have different installation images and options. We can download an installation image, buy CDs, DVDs, or USB sticks from a vendor of Debian installation media. Buy a computer with Debian pre-installed, try Debian live before installing, or use a Debian cloud image for OpenStack, a local Chemo virtual machine, Amazon EC2, or Microsoft Azure. I have downloaded from here before. As we can see, a large complete installation image contains packages from all desktop environments, making it easier to install on machines without an internet connections. We are using the stable release. We have many options for different CPU architectures: AMD 64, ARM 64, ARM HF, PowerPC, RISC-V 64, and S390X. Most of the time, we only need AMD 64 for Intel and AMD CPUs. Open your VMware Workstation application. On the home screen, click on the Create a New Virtual Machine button. This will launch the wizard that helps us define the virtual hardware for our new Linux system. We are choosing Custom Advanced. While typical is easier, Custom allows us to control specific settings like hardware compatibility, which is a best practice for learning how virtual environments are structured. This screen determines the virtual hardware version. Keeping this set to the latest available option ensures we have access to the latest features and improved performance for our Linux guests. Now we need to tell VMware which operating system to install. Select Installer Disk Image File ISO and use the Browse button to locate the Debian file ISO you downloaded. You will notice that VMware successfully detects Debian, which confirms our ISO is valid. Give your machine a recognizable name such as Debian 13.x. Double check the location path. Next, we define the CPU resources. For a smooth experience with a modern Linux distribution, I recommended allocating 2 processors. This ensures the OS can handle background tasks efficiently without lagging. Memory is vital. VMware suggests a minimum, but for a stable environment, we will set this to 2 GB of RAM. This is the sweet spot for a standard Debian installation to run comfortably. Finally, we need to choose how this virtual machine talks to the internet. We will select Use Network Address Translation (NAT). This is the most common setup. It allows your virtual machine to share the IP addresses of your host computer, providing an easy, secure way for your guests to access the internet. In a professional environment, understanding these network modes is critical. NAT is excellent for general use, but you will later learn about breached mode when you need your VM to act as a standalone device on your physical network. Next, we select the I/O controller type. You will see several options here, but LSI Logic is the standard high-performance choice for most Linux distributions. It acts as the bridge between our virtual machine and the storage device, so sticking with the recommended default ensures the best compatibility and stability of Debian. Now we choose the disk type. We are selecting SCSI. SCSI drives are efficient and standard for virtualized server environments, providing excellent performance for the read and write operations that our Linux system will perform. Since this is a fresh install, we select create a new virtual disk. This tells VMware to allocate a specific file on your physical hard drive that will act as the disk for your Debian system. Now let's define the space. While 20 GB is the minimum, I recommended setting this to 50 GB to ensure we have plenty of room for software packages, logs, and future projects. Also select storage virtual disk as a single file. This keeps all your data in one easy to manage file on your host computer. This confirms where the virtual disk file will be saved. We will keep the default naming convention provided by the wizard. Take a look at this summary screen. It lists everything we have configured, or memory, processor counts, and the virtual disk size. If everything looks correct, click Finish. We have now successfully created the virtual container for our operating system. The virtual machine shell is now ready. This is a crucial step. Modern Linux distributions like Debian 13 prefer UEFI for better security, faster boot times, and compatibility with modern features. Since you have already created the VM, we will use the virtual machine settings menu to modify this. Right click on your Debian machine in the left hand library and select settings. This is our control panel for all the virtual hardware we just defined. In the settings window, look at the top tabs and click on the options tab. On the left list, select advanced. You will see a section labeled firmware type. By default, it is likely set to BIOS. We want to change this to UEFI or Unified Extensible Firmware Interface. Is a modern standard that replaces the legacy BIOS, offering better security features and support for large hard drives. Be careful with these settings. If you have already installed an operating system using BIOS, switching to UEFI afterwards can cause the system to become unbootable because the bootloader on the disk won't match the new firmware mode. Because we are doing this before starting the installation, it is perfectly safe. Your virtual machine is now set to UEFI. You are now ready to power on the machine and begin the Debian installer. Click the Power on this virtual machine button. You will see the Debian boot menu appear. Use your keyboard arrow keys to highlight graphical install and press enter. This will launch the user-friendly installer interface, which makes the setup process much easier to manage. The first set of screens asks for your preferences. Select your language, your country, and your keyboard layout. These settings are important as they determine your system's date, time, and how your keyboard interprets special characters. Next, we set the host name. This is essentially the name of your computer on a network. I suggest something simple and descriptive like Debian 13X. Keep the domain name empty unless you're in a specific corporate network environment. I set lab.local. Now we handle security. First, set a root password. The root user is administrator of the system. Treat this password with extreme care. Next, create a regular user account for yourself. In Linux, it's a professional best practice to perform your daily work as a regular user, not as the root administrator, to prevent accidental system damage. When you reach the partitioning method screen, you are deciding how the installer interacts with your storage. Here is the explanation for each choice. Guided use entire disk. This is the simplest method. The installer wipes the chosen disk and creates a standard partition table. Extension 4 for root plus swap and so on. It is perfect for beginners who don't need the advanced flexibility of LVM and just want a working system quickly. Guided use entire disk and set up LVM. This is the industry standard for Linux installations. By using logical volume management (LVM), you're creating a layer between the physical disk and the file system. This allows you to resize partitions, add more disks, or take snapshots of your system later without needing to reformat or move data around physically. Next one is guided use entire disk and set up encrypted LVM. This option uses LVM but adds full disk encryption (LUKS). Every time you boot the computer, you will be prompted for a passphrase to decrypt the drive. This is highly recommended for laptops or any device that could be physically stolen, as it protects your data from unauthorized access. Manual. This is for advanced users. It allows you to define a specific partition size, mount points, like custom settings for /boot, /home, or /var, and choose different file system types like B3FS or XFS. Choose this only if you have a specific architectural requirement for your disk layout. I am going to use the LVM approach. Choosing guided use entire disk and set up LVM is a professional standard. After selecting LVM, you will be prompted to choose a partition scheme. This dictates how your data is organized across the system. Here is a breakdown of the option provided. All files in one partition. Best use case, beginners and personal desktop. Why choose this? Simple and low maintenance. This is no risk of one specific area filling up while others have free space. Next one, separate /home partition. Best use case for desktop users. Keep your personal files, documents and settings separate from the system files. If you need to reinstall the OS, your data remains untouched. Next one, separate /home, /var and /tmp. Best use case for power users and developers. Isolates system logs /var and temporary files /tmp. If an application creates massive logs files, it won't crash your system or fill up your root directory. Next one, separate /var and /srv. Best use case for servers, optimized for hosting services like web servers or databases, where data directories need to be isolated from the system core for security and stability. For most students starting out, separate /home partition is the best balance of flexibility and safety. It protects their personal data if they ever decide to upgrade or reinstall Debian. Finally, ensure you select Finish Partitioning and confirm your choice by selecting Yes to confirm the change to your virtual disk. The system is now formatting the disk and preparing to install the core operating system. This will take a few minutes. The system is now proceeding through the core installation. We have reached the stage where we configure the package manager. and select the software to be installed. The installer is now reaching out to Debian repositories. It will ask to scan extra media, select no. When asked for the archive mirror, sticking to the default. deb.debian.org is perfect. If you aren't using a specific corporate proxy, simply leave that field blank and continue. You will see a question regarding the popularity contest. Selecting no is a standard for a private lab environment, as it prevents your system from sending anonymous usage data back to the Debian project. This is a key step. You need to select your software, keep Debian desktop environment, and standard system utilities selected. I recommended choosing GNOME if you want a modern, polished interface. This selection defines the base look and functionality of your new Linux system. Finally, the installer will ask about the grub bootloader. Grub is the software that tells your computer how to start Linux. Congratulations! The installation is now finished. Click Continue. The virtual machine will automatically reboot and you will be greeted by the brand new login screen of your own Debian system. Once you see the desktop for the first time, don't forget to remove the virtual CD/DVD drive, ISO, from your VM settings, so the machine doesn't try to boot into the installer again next time. Log in with your user account. Once you are on the desktop, click the Activities button or open your Applications menu and search for Terminal. In Linux, the terminal is our primary tool for system management. To check if our VMware tools are already installed, type the following command: dpkg-l pipe grep open VM tools. This command asks the system to list all installed packages and filter specifically for OpenVM tools. If you see a list of items returning, they are already installed. If the terminal returns to a blank prompt with no output, it means the packages are missing. If you found that the tools were not present, we need to install them. I'm gonna show you how. First, update your local package list by typing apt update. Because sudo is not enabled by default in a standard Debian installation, I switch to the root user. Then I will explain what sudo is and why it is useful. I've got error. The Debian installer adds the installation DVD as an apt software repository. After configuring internet repositories, the DVD repository is no longer needed. We could remove or comment it in /etc apt sources.list to prevent apt from searching for the installation media. And I'm gonna run apt update to refresh the package cache from the online repositories only. Apt install open-vm-tools-desktop. We choose the desktop package because it includes the drivers required for advanced features like seamless mouse integration and dynamic screen resizing. Now sudo. Why sudo is good and how to enable it on Debian. Sudo stands for super user do. It allows a normal user to temporarily perform administrative tasks without logging in as the root user. Why it is good idea? There are 4 main reasons. First, security. Instead of working as the root user all the time, which can be dangerous, you stay logged in as a normal user. This reduces the risk of accidentally deleting files or changing important system settings. Second, accountability. Every time someone uses sudo, the action is logged. This means the system administrator can see who executed privileged commands and when. Third, convenience. You don't need to log out and log back in as root. You simply place sudo before a command whenever administrative privileges are needed. Fourth, control. Administrators can decide exactly which users are allowed to use sudo by adding them to the appropriate group. Now let's see how to enable sudo for a user on Debian. Step 1. If sudo is not already installed, become the root user and install it. apt update, apt install sudo, it's already installed. Step 2, add the user to the sudo group, user mode -ag sudo mbahmani. The -ag option means append the user to the group without removing them from any existing group. Step 3, the user must log out and log back in so the new group membership takes effect, or reboot simply to take effect. Finally, test that everything works. Sudo who am I? As you can see, I've got root. This confirms that the user has temporary administrator privileges through sudo. In practice, using sudo is considered the standard and safest way to perform administrative tasks on Debian and most Linux distributions. You have now completed the essential setup for a Debian 13.6 virtual machine. You have created the hardware container, configured the firmware, installed the system, and ensured the virtualization tools are active. You are now ready to begin exploring the Linux environments. To finish our session, we must shut down the system gracefully. Clicking the power off option in the desktop menu tells Linux to close all running applications and flush data to the disk, which prevents file system corruptions. Never simply kill a virtual machine via VMware unless it is completely frozen. Always shut down from within the guest OS first. Now that the machine is powered off, we want to save this clean state. Go to the VM menu at the top of your VMware window, hover over a snapshot and select Take a Snapshot. Name this snapshot Clean Install. Think of this as a save game point in a video game. If you make a mistake later while learning, you can simply restore this snapshot and the system will return exactly to this moment. That's enough for now. See you in the next session.